All right, so first question we're going to take a look at is graphing. And this is graphing parametrically. So remember, when you're graphing parametrically, they'll give you a formula for x, a formula for y. And the first thing we have to do is type those two formulas into our calculator. Excuse me. When we set the mode, you're going to make sure you press mode and you go to parametric. Okay, so that's the mode we have to be in to graph that. Okay, I've already typed in the two equations, 3 cosine t and 2 sine t. So now I've typed them in. Remember, the button for t is the button that normally would give you x when you're doing it parametrically. Okay, before I hit graph, what do I need to set first? Yeah.
Your window.
Yeah, I've got to set my window, and I've got to think a little bit about my t step, my t min, my t max. When we're dealing with sine and cosine, what should be your t min and t max to make sure you see the whole graph? And we're dealing with radians this time. Yeah?
Is it 0 to 2 pi?
Yeah, we're already on 0 to 2 pi from a previous problem, so that's going to work fine. Okay, so we got to go 0 to 2 pi. Remember, your t step should be a small enough number that the curve looks like a curve. So I'm going to do 0.05 pi. So that's, if you go from 0 to 2 and you go by 0.05, that's going to graph a bunch of points. It's going to be, we're going to have a lot of points. Now we're going to think a little bit about the window. For cosine, what's the biggest and smallest that cosine will ever be for its range? Yeah.
1.
1 is the biggest.
The smallest would be negative.
Okay, so cosine is always between -1 and 1. So if you triple that, that means your x is always going to be between what number and what number? Yeah?
-3 and 3.
Your x is going to be between -3 and 3. So I would do an x min and max. I wouldn't do that. That's too much. Let's do like -4 to 4. And what's sine always between? When we graph that. Yeah. -1 and 1. And if you double it, you would be between
2 and -2.
2 and -2. So I would say for our y's, let's do -3 to 3. Okay, so we got everything set in the window. We get the equations typed in. If we hit graph, this should look pretty good. Okay, and that's the graph we get. So it looks kind of like an ellipse. Right? It's 3 units from the center to the edge horizontally, and 2 units from the center to the edge vertically. So kind of like a circle, but a little stretched out. And that's how you graph parametrically. Any questions on that one? All right, so next question we're going to look at is eliminating the parameter. When you have to eliminate the parameter, they'll give you 2 equations, one for x, one for y. And the goal when you're done is to have y equals without any t's on the other side. So what's our first step to eliminate the parameter? What's the first thing we do? Yep.
Did you say solve for t?
Solve for t in which equation?
In the x one?
Yep, in the x one. So what I'm going to do first, because I don't want to deal with that -t, I'm going to just move the t to the other side. So it's going to be x plus t equals 3. Right? And I did that purely so that t is no longer negative. Now it's positive. And Aiden, what would be my last step to get t by itself there?
You divide the x. Or subtract the x.
subtract x. So that would mean t is going to equal,
T equals 3 minus x.
yep. Okay, so now we've got a formula for t. What am I going to do with that formula? Yeah, Meg?
Plug it into the y formula, so it's y equals 3 minus x squared plus 1.
So y equals, and yep, we're going to fill that in. 3 minus x squared plus 1. So that's our new equation. Okay, any question on how we got that? Now, when we draw this, what shape is that?
Can I please have Tyler?
So what shape would you draw that? Yep.
Isn't it just like an angled line because it's y equals x plus b?
Well, it's raised to a power though, right? It's raised to
That'd be a parabola.
That's a parabola, yep. So when we graph this, the original problem had limits on what you were going to plug in for t, which means when you graph it, the new equation also has limits. We have to figure out how far left and how far right we should draw this parabola. So it's a section of a parabola. So to figure that out, what I did was I put in 3 minus t for x, t squared plus 1 for y, and for my parameter, I filled in 0 to 4. If we look at the endpoints, will the endpoints tell me how far left and how far right the graph goes?
Yeah.
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 It's not like the endpoints, like if you had something like this for endpoints, and the graph did this. Well, now the endpoints don't tell you how far left and right it goes.
Yeah.
That's a lot more complicated. Now you got to figure out what's over here and what's over there. But in our case, we're okay. We've got that point, and we've got that point. All right, so now we got to just figure out how far left and right it goes. We don't care up and down. When you're describing the restriction, it's always on the domain, not the range. So what number would I plug in to figure out my x value for my start point? Yeah.
3.
No, not 3. Anybody have an idea what number? This number controls the start point of the graph.
D plus 1.
It doesn't have anything to do with the work we've done so far. It has to do back with what they gave us originally. Yeah?
0?
You're going to plug in 0 to figure out the x value of your start point. So if we plug in 0 for t, what's going to be the x value for where my graph starts? Yeah,
3.
3. So my graph is going to start, and we can see it's right at 3. So it starts at 3, and that's actually going to be the highest. This graph is drawn right to left. So 3 is the highest it ever goes. And then the lowest it ever goes, what value are we going to plug in for t to find the end point? Yeah.
4.
Yep, we're going to plug in 4. 3 minus 4 gives me -1. So to graph what you're seeing right there as a function, you would draw this parabola from -1 to +3. And that's how you eliminate the parameter. All right, so next question we're going to look at is graphing in polar. So we're going to graph these 4 points. And we've got some in radians, some degrees, some positive, and some that are negative. So let's start with the first one. That's a positive, positive. When you graph a point in polar, what is the first number? It's your, what do we call the first one? Yep.
Distance from the origin.
The distance from the origin, and what's the letter we use to represent it?
R.
R. Yep, so your first one is R. And the second one is your angle. And Aiden, do you remember the letter for that one?
Delta?
Not delta, that is a Greek letter, but not the one we use here. What's the Greek letter we use for an angle? Do you remember what the letter looks like? What the symbol for it is?
Like, you mean like a symbol or like a
Greek
like an
letter.
actual letter?
Yeah, the Greek letter.
Theta.
Theta, yep. So it's R and then theta. So it's the circle with the line in the middle. All right, let's start with 345. How would you graph the point 345 degrees? Start by, yep.
Measure the distance like from the origin to 3 rings out.
Okay, can you be a little bit more specific?
Like the R3 would be like the third circle away from the origin.
So go like 1, 2, 3 over here?
Yeah.
No, you don't want to go down there.
Or no, it should be from the right.
To the right.
Yeah.
So we have to go 3 units to the right. 1, 2, 3. And then after we go 3 units right, what do?
We find the angle, which is 45, so that should be
So we're going to rotate 45 degrees. And which way?
counterclockwise.
Counterclockwise. So you would end up 1, 2, 3, and then 45 degrees. That is how you graph number 1. Okay, let's try number 2. -2, 60 degrees. Megan, how would I graph that one?
You would go 2 degrees to 2 units to the left,
So 2 units to the left, yep.
and then you would go counterclockwise 60 degrees.
Counterclockwise 60 degrees. 15, 30, 45, 60. That's going to put me right there. Okay, so that's point number 2. So left 2 units, and then counterclockwise 60 degrees. Okay, number 3 is just like number 1, except it is in radians. What's 2 pi over 3 in degrees? So pi over 3 would be 60.
It's 120.
So it's 120. So we have to go right 5. 1, 2, 3, 4, 5. 90 plus another 30 brings me to 120. So that is number 3. And how about the last one? -4, -pi over 2. What would be my first step in that one? Yeah.
You go back 4.
And which way is back?
Left.
Yep. So we're going to go left 4. 1, 2, 3, 4. So we're going to start from right there. And then we need to rotate -pi over 2. Which way?
Clockwise?
We go clockwise. Yep. And pi over 2 is how much in degrees?
45, maybe?
So pi over 4 would be 45. Yep.
Is it 90?
90. Okay, so you're going to go left 4. 1, 2, 3, 4. And then 90 degrees clockwise. And that's where that one would be. Okay, so you'll have a couple like that on the test. It could be a combination of degrees and radians, positives and negatives. Any questions on graphing those 4? Okay. All right, so next 2 questions we're going to look at are converting between polar and rectangular. Okay. When you have polar, can someone remind me again, what are the two things that were given? Yeah.
R cos theta, R sin theta.
So we're given the R and the
Degree.
theta.
Yeah.
So now we need to convert the R and the theta into a what and a what? if we're doing rectangular. Yeah.
X coordinate and Y coordinate?
Yeah, we need an X and we need a Y. So when we're done, that's going to be our answer right there. How do you figure out, or what's the formula to calculate the X coordinate using the R and the theta? Yeah.
It's the R cosine theta.
Yep, it's the R cosine theta. And what's the formula for the Y? Do you remember that one, Aiden?
Is it R sine theta?
Yep, R sine theta. Okay, when your angle is a multiple of 30, you're going to get a nice answer that's on the unit circle. So we're going to figure out what the cosine of 60 is first. So it's going to be 5 times something. If you don't remember the cosine and sine of 60, you can type it in, but you need to recognize it as an exact answer. Okay, let's do cosine, but let's do it in degrees. Okay, cosine of 60. Well, that one's not bad. Okay, we just get 0.5, which is a half. Now, when you're dealing with a multiple of 30, if one of them comes out without a square root, the other one will have a square root. Okay, when I do sine of 60, I get 0.866, but I need to recognize that as a special number. What is 0.866? Yeah?
Root 3 over 2.
That's root 3 over 2. Okay, that comes from the unit circle. So root 3 over 2. You do not have to worry about an exact answer unless it's a multiple of 30 or 45. What's the other special number that can come up from the unit circle besides root 3 over 2? It's not going to come up in this problem because we're not dealing with a multiple of 45. But anyone remember the other special number? Do you remember? No? Yep.
Root 2 over 2.
Root 2 over 2. Yeah. It's the other special number in the unit circle. Okay. So when we multiply this out, what's if you write 5 times a half as a fraction, how would you write that? Yeah. Yeah, I would just do 5 halves. So that is your x value. And what's your y value going to be as an exact answer? Yeah.
5 root 3 over 2.
5 root 3 over 2. That's the kind of answer I would expect to see when you're doing a multiple of 30 on the test. All right. So any question on changing from polar to rectangular? Okay, so probably I'll take 2, maybe 2 of those. And then 2 of these, convert to polar. All right, so if that's convert to polar, what does that mean that they're giving us here? What's the negative 2 and then what's the 7? Yeah.
Negative 2 is x and 7 is y.
And 7's y. And what is it that we are trying to get? Yeah.
The R and theta.
We're trying to get the r and the theta. Good. All right, so now we got to figure those out. First thing we need to do is graph it. And even if we don't graph it, then we really just need to figure out the quadrant. What quadrant is negative 2, 7? Yeah,
Quadrant 2.
that's quadrant 2. Left 2, up 7. When you are in quadrant 2, what is the formula for finding theta? Yeah.
Tan negative 1 over x.
And what do you call that tan negative 1? Well, arctan, yeah, or inverse tangent. So inverse tangent, and what did you say again? Of what?
Y over x.
Y over x. 7 over negative 2. Now, because we're in quadrant 2, we need to do one more thing with that formula. What do we have to do? If we forget this, it will be wrong. Yeah.
Is it add 180?
If we're in degrees, we need to add 180. Or if we're working in radians, we need to add pi. Yep. So let's take the inverse tangent of 7 divided by negative 2. And then we can add 180. And you should get 105.95. That's your angle. Okay, so I can, if I want, I can fill that part in right now. 105.95. And the last thing I need is my radius. So think of the point that we just put as being on a circle. And how would you figure out the distance from there to there? Yeah.
R is x squared. R squared is x squared. That's y squared. So it would just be root x squared plus y squared.
Okay, so we're going to make a triangle. This side is on the bottom is how long?
2.
And the height?
7.
7. And we're going to do Pythagorean theorem with 2 and 7. So R would be the square root of how much?
53.
Yep. And that is how you change a point from rectangular to polar. Remember, there are 4 different ways you can write that point. Another way, instead of going 105, like that, what could we do to the 105.95 to get another answer? Yeah.
Subtract it by 180 by 105.95.
So subtract what number from that?
180.
We can't subtract 180 and keep the radius positive.
I meant like the other way around, like 180 minus 105.95, because that wouldn't produce the same positive, right?
Yeah, so if we do 180 minus 105, we won't get the same.
Okay.
We won't be in the same spot. We'll be at a different point. But what else? What's something we've done to that angle before to change it from like negative to positive or positive to negative? Yeah.
Is it you subtract or add 360?
Yeah, and if you wanted to go the other way in this problem, you could subtract 360 from 105.95, and it would give you that red arc. Okay, so that would be another way you could get an answer. When you write a point in polar, there's up to how many different answers? Yep.
4.
Up to 4. As long as it's not on the polar axis, there is up to 4. Good. Okay, so for our last question, we're going to take a look at drawing something in polar. This particular curve is called a lemniscate, not one that we looked at in class, but I think once we draw it, you will recognize the special symbol that it is. All right. So to put that in on the calculator, we have to first, let me fix the problem. We have to type that in. So it's going to be the square root of 9 cosine 2 theta. And I will put that in on R1. So this is in polar mode. So you've got to make sure you go to the third option over on the right. All right. Before we hit graph, what should I check? Yeah. Yeah, we're going to check the window. All right. We're in degrees, so we want to make sure we go through a full cycle. What's the period length of cosine 2 theta? Period of cosine theta is 0 to 360. But what's cosine 2 theta? Yeah?
720. Would
Um,
be the opposite way, like.
the other way.
Yeah, 180.
180. Remember, the formula is 2 pi over b. In this case, it's 2 pi over 2, or 360 over 2. So if we go 0 to 180, I think we should get the full picture. Because this problem originally was a square root, and we're not graphing the negative part of the square root, we might not. So let's try it and see what happens. So if we go 0 to 180, yep, that's why with the original problem, they also had the negative of that, which, if I put that in, we will then get the full picture. So, negative square, negative second square root 9 cosine 2 theta. With the negative, that gives us the full picture. All right. If you set your parameter to go beyond 180, you can get that full picture without doing the negative square root. So there's different ways to get the full picture. But what we have there is an infinity symbol. Okay. So make sure when you set it that your t-step isn't too big. Okay. If you go by like tens, is that a good picture? No, not. We lost some detail in the middle and it started to get kind of blocky. So the lower you make that number, the more detail you'll start to get. That's better. But it's still not low enough to get the precision that we need in the middle. I think for that we needed to bump it down to around like 1 or maybe even 0.5. But 1 might do it. Yeah, that'll be fine. Okay, so any questions on graphing that in polar?